So I'm just going to run through the 3 that were on that worksheet because a few of them caused problems. Okay, especially the last one. Right, so running through the first one. The first one everyone seemed to get, that wasn't a problem. So writing the oxidation numbers +1, -2, -1, +1. Of course, this one is -1, this is 0, +1, -2. Okay, having a look at what's happening. The Cl goes from +1 to -1, so therefore it gains 2 electrons, and the I- goes from -1 to 0, so it loses 1 electron. So my common denominator then, of course, is 2. So rewriting that equation, ClO-, I'm going to need 2 I-, 2 I- plus H plus, giving me Cl- plus. Now I2, look, I already have two I- here, so I don't need to put another number in front of this. Plus H2O. Right, count the oxygens. So my oxygens are, here, I've got 1 oxygen on the left and I've 1 oxygen on the right. 2 hydrogens then on the right, which means I'm going to have 2 hydrogens here on the left. Okay, the second one. Writing the oxidation numbers, +7 -2, -1 +1. This one becomes, of course, +2, 0, +1, -2. Okay, let's see what happens. This goes from +5 to +2, so that gains 5 electrons. The I- of course, goes from -1 to 0, so it loses 1 electron. So this time my common denominator between 5 and 1, of course, is just 5. So I'm going to rewrite this equation now. MnO4- plus I- plus H plus is giving me Mn plus 2 plus I2 plus H2O. Okay, so I need 5 of these here. 5 I- to give 5 electrons here. So that's going to become 5 I-. Now once I have a 5 I- there, that means over here I've got I2s. So this will become 2.5. 2.5 O2s. Okay, count my oxygens. I've 4 on the left, so I want 4 on the right. I've 8 hydrogens now here, so I'll put 8 there. Now then, if I wanted, because you don't often see balanced chemical equations with fractions, I could just double everything here. So this would become 2 of those, 10 of these, 16 H pluses. That will give me 2 Mn plus 2s, 5 I2s, plus 8 H2Os. And you can see I have 10 I's on the left, 10 I's on the right, 2 M's on the left, 2 M's on the right, 8 oxygens here, 8 oxygens there, and 16 H pluses. Okay, now the last one, as I said, which did cause a few problems, so let's have a look at it. So looking at the oxidation numbers, this is +1, of course, again. This is +7 -2. This one is -2. An overall charge of -2 means that each of those carbons has to be +3. Carbon over here, if that's -2, has to be +4. This, of course, is +2, +1, -2. Okay, so let's see what the changes are. Manganese goes from +7 to +2, so that means it gains 5 electrons. This carbon here, part of the oxalate, goes from +3 to +4, so of course it loses 1 electron. Now I'm going to be careful here. Each carbon loses 1 electron, but I've got 2 of them, so that means really the number of electrons that are going to be available is 2. So 2 carbons between them are going to lose 2 electrons. Each manganese needs 5. So I need a common denominator between the 5 and the 2. In this case, okay, it's 10. Okay, so rewriting. I've got H plus MnO4- plus C2O42- gives me CO2 plus Mn plus 2 plus H2O. Okay, so look, each manganese needs 5 electrons. Therefore, if there's 10, we're going to have to get our 10 electrons from here, from 5 carbons. So this one, and I've already taken into account the doubling of those electrons, so I'm going to have 5 here. So that means that if there's 10 electrons about knocking about from these carbons, they'll be picked up by the 2 manganese here, because each manganese needs 2. Sorry, each manganese needs 5. Now I'm going to count the oxygens. I've got 4 2s are 8 and 20, so 20 altogether. Oh, I haven't done the carbons over here. So this carbon, I've got 10 carbons on the left, I'm going to have 10 on the right. I have 2 manganese on the left, 2 manganese on the right. So now counting my carbons, I have 8, 28, 20 already here, which means I'm going to need 8 waters. And if I've got 8 waters, then that's going to be 16 H pluses. So this one was more difficult. This bit here is very important. See this bit here? So have a go at that one again, girls, and see can you get it right.